Hi, Rick Watson, Senior Marketing Manager at Huawei. We've actually got today our demonstration of our petabyte switch. We're actually taking the core and taking out the electrical platform inside the core so that we can actually do an OOO conversion. It actually helps us scale up past the terabit range and into the petabyte. What we've got behind us here is a demonstration that kind of shows a piece of that and the technology we're showing. So we bring it into the outside edge on an ODU basis. We bring it into what we call our optical burst technology. We utilize that to help us scale into the center core, and the center core takes it and up beyond the terabit range into the petabyte. With it behind us here, we've got the two shelves, the shelf on the left and the shelf on the very right hand side are actually the edge, and in the center is our core. And we actually show in the switching capacity that we can actually take a video that we've got on one screen, do a switch, and actually show it up on another end. So this allows us to actually demonstrate what we've got going on in the core itself. Thank you and have a great day.
We're here to talk about very large-scale cross connects, and we had a chance to preview a demonstration at the Huawei booth at OFC and FOEC. So I'm here today with resident Huawei expert Kent Jordan. We're here to talk about cross connects, and I'd like to ask Kent a few questions. Kent, what do you suppose the key drivers are for this type of technology to get deployed in the network?
Well, the primary driver is traffic growth. So we're seeing globally IP traffic growing at a rate of around 35 to 55%. And for example, in China, we're seeing backbone capacity at around 64 terabits per second. And we expect that could grow as high as 200 in the 2016 timeframe.
Wow.
So that'll require us to move to higher line rates beyond 100 gig, which we're deploying now. So we'll start to see 400G and a terabit appear in the network. And as those higher bit rates proliferate, we'll need higher switching capacities at the node in order to manage that traffic.
Wow, that's quite a bit of bandwidth. Can you give us any idea of what kind of switching capabilities are going to be required to manage this type of bandwidth?
Well, a traditional electrical-based switch has real challenges to scale to a petabit level switching capacity due to the power required, the space requirements, the ability to interconnect all the multiple shelves that would be required. So Huawei has introduced some novel technology to basically take a cluster-based approach to the switching platform. We have a centralized switch that is a purely photonic switch leveraging our OBTN, our optical burst transport network technology. So the entire system functions as an OTN cross-connect and provides ODU 0 level granularity switching, but it's done in a purely photonic way so that you get lower latency, lower power, and so on.
So what are the applications you see for this type of technology?
Well, there's two primary applications that we're seeing. One is a kind of large-scale optical cross-connect that could be used in the core of the network, and the second is more of a data center cross-connect. So to elaborate a little bit more on the first, we would see it kind of being able to provide a bandwidth grooming function for a very high capacity node where you've got multiple 100 gig, 400 gig, perhaps even a terabit wavelengths terminating, being able to do both ODU 0 level grooming and just wavelength management. It could also be used to provide a bit of a router bypass functionality, if you will, to offload those core routers as capacity is really growing in the network. And then the second application is more of a data center application. So you can imagine a data center is almost a small network within a single building. And those have grown to extremely large capacity connections to interconnect various routers, aggregation routers, core routers. So we see that the PPXC could fit directly into that to be able to do switching for connection between routers at a data center.
Thank you, Ken, for sitting down and talking with us today. It's been a pleasure.
You're welcome, and thank you for having me.